Hello, everyone. Welcome to another episode of the Index Podcast, where we come together every couple of weeks to discuss on-chain data, chart crimes, and metrics that move the crypto industry. Today, I have with me Denning, Chief On-Chain Sleuth at Pantera Capital.
Oh.
Norbert, Hungarian Army Knife at Zenith.
Hi, everyone. Yeah, that's the nickname we figured a few days ago.
Yeah. And I am Boxer, and I am, of course, the community powers at Dune. Before we start, nothing we say here should be relied upon as legal, financial, investment, tax, or even life advice. We're acting independently of our respective professional roles. And with that, welcome, Norbert. Thanks for joining the podcast. And we are going to continue on our adventure in understanding Canton today. So Canton, of course, being a privacy-first network, not a lot of stuff for us data analysts to really look at. But nevertheless, I think one of the kind of like broader trends of the institutionalization, oh my god, it's a hard word. Institutions are coming on chain and they're choosing to use Canton for various reasons. But maybe before we go there, Norbert, what does Zenith do in relation to Canton?
Hi, thank you very much for having me here. It's a real pleasure. So, yeah, basically, Zenith is building an EVM extension to Canton. As you know, Canton has its own language, DAML. So if a developer wants to build an application on Canton, they will need to learn a new language, specifically because the EVM and the EVM toolkit is the most adopted across developers. Very often it's a challenge or kind of like a bottleneck to slowing down the development when they are facing the need to learn a whole new language. Obviously, many of the teams that want to come to Canton have already built applications on EVM or Solana, etc. And they when looking at it may become a headache to rebuild everything, specifically from the risk surface, the audit surfaces, the hardening and better tested state of existing DeFi protocols, for example, versus rewriting everything in a new language. And we allow Ethereum and soon Solana developers to lift and shift their existing applications or just write applications in Solidity or Rust in Solana, and to deploy that on Zenith EVM and later, as I mentioned, Zenith SVM, where these applications, as soon as they are live on Zenith, they are from the first moment atomically composable with Canton native applications and Canton native assets, essentially. So that's kind of like the core feature, I think, or the core novelty that we bring to Canton, where we allow developers to build applications that are composable with Canton in other languages than just DAML.
Okay, that's a lot. Maybe we'll dive into all of these aspects in a little bit. Maybe just like a 1 minute, like who are you? How did you get here? Maybe what's your kind of like official position within Zenith?
Oh yeah, thank you very much. So I'm head of product at Zenith. I joined the blockchain space about 5-6 years ago. Prior to that, I spent 12 years at the United Nations in different positions. But when I started learning about the potential of programmability on Ethereum and all that, all the things that it may unlock, I fell into the rabbit hole, and after quite a bit of studying, I transitioned full time. I joined Zenith and the team behind Zenith about almost 3 years ago. As a protocol researcher, I was mostly focusing on mechanism design and crypto economic related research and protocol design in our team. And then I slowly transitioned into leading the product side, where I'm working with our clients, coordinating integrations, working closely with our engineering team, but also our potential clients. And I've done a bunch of ZK related mechanism design type of research prior to Zenith. ZK is my other kind of one of my other favorite topics, and I fell into that rabbit hole as well. But yeah, that's a whole different story.
Maybe, so you've been at Zenith for 3 years, you say. Has Zenith been working on this specific like EVM on Canton integration for the entire duration, or is this kind of like a pivot from something else that was prior?
Mm-hmm. So basically, we've been working on ZK infrastructure about 3.5 years ago. We've been working with most of the layer 2s on Ethereum very closely with the Ethereum Foundation around the ZK path and the snarkifying of Ethereum itself. We were one of the first teams real-time proving Ethereum. We were the first team actually to prove every single Ethereum mainnet block through a grant that we received back then from the Ethereum Foundation. And approximately a year and a half ago, I think it was early 2025, when we discovered the Polyglot Canton white paper, where Canton talks about the need for EVM composability, for more global composability for the network, allowing developers to write applications in other languages than just DAML. And we started looking into it. We built internal MVPs, and actually then finally we figured we could build this EVM composability for Canton. We made a proposal to the digital asset team and the super validator and the governance body of the Canton network. And after quite a bit of iteration on what the design should look like, we nailed down all the aspects, got and started building. Actually, that's when we became a super validator on Canton. So when you bring meaningful improvements and value additions to the network, the way it usually works is that you are creating a Canton improvement proposal. In our case, it was to build the EVM compatibility layer and to, like, from the technical side, and also to bring certain adoption and growth related, or meet certain adoption and growth related milestones. And in return for that, as we deliver this, we earn a super validator slot with full weight and with all the governance rights and all the reward structure, etc., around it. So we've been a super validator since November, I think, last year, when we started officially working on Zenith EVM for Canton.
And maybe just to reiterate on your initial pitch, if I repeat this back, you're essentially Canton's native programming language is DAML, and they just completely made this up. This is like not. I read somewhere that's like similar-ish to Hexel. So like I guess like some Cardano folks might be familiar, or like they might be able to read this a little bit, but like it's essentially like it's its own programming language. It's like loosely based on some like existing concepts probably, but like this is just a net new thing.
Yeah. So basically, what a little bit of context behind. They finally ended up, or to the best of my knowledge, ended up building DAML because they were trying to find the language where they could express the necessary financial workflows in a way that institutions could, use it. It's privacy preserving. It's still enabling composability across networks, etc. And they found that the best would be to build a language, because none of them was actually fully capable of enabling that. And yes, as you mentioned, DAML is Haskell based, so actually Cardano folks may have an advantage there if they want to build on Canton in DAML. But this is how the network landed with a whole new language, which ensures privacy. Actually, we could even call it sub-transaction privacy, because it's not that only the participants involved in a transaction see the different sensitive data in the transaction, but sub-transaction privacy means even the different parties involved only see the data of the transactions that is relevant to their part of the work, to put it simply.
Okay. Interesting. I guess it's like I looked at some kind of like high level mockups and some very simple contracts, and to me it just seems like a way to express like contracts, like traditional like contracts that are governed by law into code. And like, you know, if you read an Ethereum contract, there's like a lot of whatever state management and like this needs to be a new 256, this needs to be var binary, like all of this stuff. In Canton, I didn't see anything of, maybe I just didn't, or like in DAML, I didn't see anything of this. Is that kind of like your understanding as well? Or like, what's a good way to think about this?
I think your understanding is basically correct. The way I usually also put it is that Canton is actually able to express traditional financial workflows on chain, and basically everything in Canton has been built around this to enable this and to ensure that the workflows that financial institutions see on the network are actually kind of mimicking the workflows that they are already used to. And that's what, so the language is able to express that. For example, I mean, just a very simple example, in case of a bank transfer, for example, it's only you, me, my bank, and your bank who knows about the bank transfer. It's exactly the same on Canton. My wallet is hosted by a Canton validator. Wallets or like parties are smart contracts on Canton, so they need to be run by a validators, because not all contracts are run by all validators, like on a public chain like Ethereum. Here, only the validators that are hosting your contract are actually executing the transactions. So your validator that hosts your wallet or party, and my validator who hosts my party, and you and me would know about my transferring, making a transfer to you, for example. So it's a very similar concept. Obviously, I'm simplifying here, but I think it's easy. It's an easy way to understand the logic, how the network is constructed, kind of.
Yeah, it's a very unique property of Canton. I essentially don't know of anything other. I think the Polygon team had like some research, whatever thing. But anyways, so is that also why? So let's kind of like there's DAML, and you are essentially saying like, hey, in DAML there might be some missing like expressions or like complexity that I can model, or is it just about kind of like I don't have like a established history of code that I can use in kind of like business critical applications. So there's no Morpho or like Aave implementation inside of DAML that I could just kind of like port or like use and kind of like be safe. So you're saying like that's why I need an EVM network now, or like maybe help me like find the right angle to like find the logic behind it.
Yeah, no, honestly, we are in a pretty good position, I think, with Zenith, because the need for EVM compatibility for Canton existed before we started building it, because the Polyglot Canton white paper is something that the digital asset team behind Canton actually put out a year and a half ago, and they talk about the need for EVM compatibility for Canton, because most of the applications, the programmable decentralized finance lives on the EVM side, and most of the applications have already been battle tested and running for years. So you have robust infrastructure, application level infrastructure there. And I think when talking to teams, also experience that they run into, DAML has very different logic to express application logic, so very different semantics. And because of that, it is a heavy lifting. And many of the teams that we talk to just step back and think is there any way I could port my EVM application to Canton without needing to rewrite it? because its time, its cost, its risk of any bug or anything um, remaining in the code. And basically, we started building Zenith EVM. And as we started talking to teams, there was huge interest, and even top tier EVM protocols are looking at Zenith and Canton very deeply. I mean, Canton, obviously, since the news about BTCC, about Nasdaq, about Visa, etc., came out back in December, January, I think many of the blockchain space woke up to, hey, what is this new network? And many of the applications obviously started looking into how can we tap into these institutional flows and institutional rails that Canton may have. And that's how naturally, as they started exploring Canton, they also discovered that the whole protocol needs to be rewritten in a new language. And therefore, what Zenith brings to the table is is a huge help. And, it removes all those risks that we talked about earlier. You can literally, to put it in one sentence, you can literally lift and shift existing EVM applications and just swap the RPC endpoint and deploy them on Zenith. And it's going to act just as if it was deployed on Canton directly.
Okay, let me try to understand that. Because right now it's like a fuzzy mess of things. So, okay. So Canton has these native assets. What is it, like 56 or something?
It's CIP 56. Yeah.
CIP 56. So first of all, like who issued, is it CIP 56? Is that like it's an asset that somebody issues? Let's say I have USDC on Canton. Would that be a CIP 56 or is it like some other like contract?
No, you can think about it as like ERC20 for Ethereum. CIP 56, the Canton coin, for example, but also USDCX, which lives on Canton, are CIP 56 assets. So essentially, that's, you are right. That's okay. You said that right.
So I have some of those in my wallet, which I'm not even sure like who I need to talk to even have a wallet, because I need to be like, I can't just go in there as a retail participant, right? Because like I need to be connected to some super validator to even get my transactions included.
Yeah, but actually you don't need to worry about all that. So I think it's a very good point you bring up, but because I think that may be one of the misunderstandings around Canton, because it's very institutional focused. People think it's only for institutions, but you have wallets, like I think over 10 different wallets, where just like you go to MetaMask and you create a new account, you go to any of these wallets and very easily you can create an account or a party ID for yourself. And that's going to be your party ID to send and receive assets to and from, etc. And also all this, infrastructure complexity behind that you mentioned, because there are validators and super validators involved, etc. You don't need to worry about all that because applications abstract that away. So it is very much also there and available for retail. And even though the ecosystem is fairly early, you already have some, exchanges on Canton. You have various use cases living there, and the scope and the different types of applications are growing and appearing basically week by week. So it is a growing and a widening ecosystem, I think. What we allow is, if you have EVM applications or if you have assets living on the EVM that you would want to compose with Canton native applications, for example, make them available for Canton's institutional clientele, etc., you can very easily move both your EVM applications or even your EVM assets to Zenith EVM. We have built a connector, basically an atomic interop solution ourselves between Canton and Zenith, and that allows you to move these ERC20 assets, or it could even be ERC3643 RWAs or other types of assets. You can move them to Canton and compose them in applications, and vice versa. So when you move a CIP56 asset from Canton to Zenith, on Zenith, it's going to be represented as ERC20. And you can compose that and use that in, any application that's deployed on Zenith. So it's I think it may sound more complicated than what it actually is.
And to simplify it, then, would you see Zenith as almost like a bridge, or not really?
No, the core difference is, but it's a very good point, because we do take care of asset movement between Canton and Zenith. But Zenith is an actual execution environment. So you can think about it as Ethereum atomically composing with Canton. And what this essentially means is that you can have operations that have one leg on Canton. Let's say you mentioned CC in a wallet on Canton, and you have USDC on Zenith, let's say, and you want to swap these. You can have both legs be processed at the same time, executed and finalized atomically. Either both legs go through or none. And it's not like you use these hash time lock contracts. I don't want to go into details. There are workarounds to this, but essentially the core thing to note is that Zenith is not a standalone chain. It is an extension to Canton. It lives on Canton and doesn't live on its own without Canton at all. It is Canton validators who actually sequence and drive the block building of Zenith. It is Canton validators actually who execute EVM transactions on Zenith and EVM application logic on Zenith. And because Zenith uses Canton's consensus and not like a beacon chain type of Ethereum consensus, essentially we allow EVM and DAML logic to run together in a single workflow and commit atomically. I know it may have been a mouthful, but maybe I can go one.
No, it's all good. I think Denning and me will have a bunch of follow-up questions. Maybe Denning, I think you're usually more involved in such topics, so go ahead.
Oh, yeah. No, I mean, I understand that there's no global state, but then there's this global synchronizer. So I'm like trying to understand what that is. And also on a high level, I think a good way to maybe try to understand it would be comparing the execution layer and the consensus layer in the EVM setup. How does that one-to-one translate to the Canton setup, say? How, we'll go one by one. So if you can walk us through, what does global synchronizer do?
So basically, the global synchronizer is essentially Canton network. You can think about it as a network of coordinators who coordinate cross subnet transaction flows. The super validators are the ones who are running and operating the global synchronizer, and the global synchronizer is essentially connecting different Canton subnets. Now, I think this is something very unique and important to know about Canton. There have been previous periods of, when a lot of institutional blockchain pilots happened with Hyperledger, Corda, etc. But many of those environments were private silos. You could use them internally for your institution or enterprise, but they were not composable with any external subnet or any external ecosystem. What Canton managed to figure out with DAML is actually that you can have these Canton subnets, these private institutional networks, but the global synchronizer is able to make these networks compose with each other in a way that they don't spoil privacy and they don't spoil, all the compliance and all these aspects. So essentially, the global synchronizer is focusing on message ordering and message passing across these different subnets. Mm-hmm. So if there is an application, that JP Morgan uses, and it wants to connect to Goldman Sachs' application, let's say, on their respective subnets, then the global synchronizer is the one that is, passing the transactions, taking care of the ordering of the transactions, collecting back the transaction results, checking all the hashes, the receipts, the metadata, the outputs, and then finalizing those transactions after having made sure everything is in place to ensure correctness and to verify the correctness and that both legs have executed. So it's kind of like they do not see sensitive data. They are responsible for canonical transaction ordering and message passing between these different subnets in a privacy preserving way. So the super validators do not see private sensitive transaction data. They do see, for example, Canton Coin related data, because that's a public contract. And I think also in your previous episode, this one was mentioned. They do see that there are transactions happening, but the details, the sensitive details inside the transaction are not visible to the super validators either, solely to the parties that are involved as stakeholders in the transaction. And yeah, to your second question, honestly, it's very hard to draw parallels with EVM because simply the architecture of Canton is very different. But when I want to draw a parallel with Zenith, so we use REST as the underlying execution client, which is a very standard Rust-based Ethereum client. We are 100% bytecode compatible, but we swapped the consensus element, the beacon element, to Canton's own consensus. So you can think about it as we have a block builder contract, a block proposer contract, a state contract on Canton. And when transactions come into Zenith, before they are executed and the results passed on to Canton, actually these transactions are collected and badged into a proposal on the Canton side in a Canton contract. And when this block proposal is sealed and runs through Canton's consensus, then it is distributed to the EVM validators, who are actually also run by the Canton validators individually. And with the same inputs, each validator executes the transactions, and then they compare the results, and if the results are matching and receive quorum, then they can be finalized again by Canton's validator network and consensus.
Is it necessary that every slot the validator is using Zenith? As in, like, I'm trying to understand, because like it only makes sense that you can finalize a block that you build if you have the whole control of this whole slot, right? So it's like, first, I guess my first question is like, does all the super validator or / proposer are using the Zenith layer, or some of them may not use the EVM layer?
Very good point. So Zenith was built essentially in a way that it allows any application to compose with Zenith without running Zenith EVM software, without running a node, without actually entirely being aware of Zenith. So the way to think about it is that we, as a super validator, we also run validators that host Zenith's contracts. These validators run the EVM node, but no other validator needs to deal with the complexity of running an additional EVM node, etc. It just works out of the box with the atomic interop solution that we built into our protocol. If a Canton native app wants to consume an ERC20 token, move it to Canton from Zenith and do a swap with it on the Canton side, and then return the resulting token back to the EVM side. They can do it without needing to write, specific EVM logic, or without needing to run a node, etc. This was actually one of the requirements that we had to meet to enable and to allow smooth composability between the two environments for Canton applications and validators.
Okay, but for Canton network, what's the native way of sequencing the block? Like if without the Zenith layer?
For Canton network, as I mentioned, it's when a transaction comes into Canton, it lands with the global synchronizer. The global synchronizer puts a canonical timestamp basically on it. And that's how essentially they take care of canonical ordering. And then the validators who are, or all the validators who are involved in the transaction as stakeholders from the various sides are executing it and passing back the results to the synchronizer. And then the synchronizer actually has two main functions. One is sequencing, and one is a mediator function, which checks the results of Canton transaction execution, and then they confirm finality. When you add Zenith to this, basically the same validators every 2 seconds they take the batch of transactions that are sequenced or are collected in our Canton contract, and then this goes to the synchronizer. The synchronizer puts an ordering and a timestamp, on that transaction, which includes, it could include even hundreds of EVM transactions or EVM events, and then the Canton validators hosting the EVM node can execute it once the transaction ordering and the timestamping has taken place.
Okay. So my understanding is that, correct me if I'm wrong, is that there is a native way of sequencing the blocks transactions in Canton network for the validators, and they can choose to also use the Zenith block building layer or not. But if they don't, they just have their own way of sequencing the transactions. And in this case, then Zenith is more like serving like transaction flow, almost like RPC, sending them for whatever transaction you receive.
I think
things.
Maybe we are overcomplicating it. So there are no two sequencing logic on Canton.
Is the first
Zenith,
first come, first serve?
Think about it as Zenith has a smart contract collecting transactions on Canton. And then it is actually Canton validators. So that smart contract, every 2 seconds, it actually emits a batch of transactions. And it is included in a single Canton transaction. So when Zenith block building is essentially a single Canton transaction, including all the wrapped EVM payloads that have been collected related to those transactions. And the Canton sequencing logic is unmodified. It just includes also the transaction that our smart contract emitted, including potentially hundreds of EVM payloads, and sequences that as part of Canton's canonical transaction flow. And then it comes back to our validators who execute those wrapped inputs natively and pass back the results, reach a quorum, and then the Canton synchronizer takes that quorum, checks whether everything checked out, all the signatures or the transaction receipts match, and then finalizes that single transaction. So there is no two sequencing logic. Actually, Zenith is represented as a smart contract on Canton, and when we create a Zenith block, it's essentially a single Canton transaction, including hundreds of EVM payloads, which is sequenced by the regular Canton sequencing mechanism and gets executed by our validators.
So there's one global state for Zenith.
For Zenith, yes. That state is actually living on Canton. Canton is the source of truth for Zenith's global state. And you touch a very good point, because this means that Zenith is actually public. The EVM was not built for privacy, or the EVM tooling was built for a public permissionless chain. So therefore, the EVM side of the transactions is going to be public, and it's very similar to, just like Ethereum. you will have, all the data can be indexed just like you would index it on Etherscan or any other explorer that Ethereum may have. We are exploring a private version of Zenith EVM, but that's going to be a separate instance, and we can talk about that more.
If I go back to my example where I have a wallet on Canton for whatever reason, and I now, oh god, what are we even gonna do? I'm just gonna send money into the Zenith network. So like I have the CIP56 representation of USDC, and then I can supposedly put that into the Canton network. Into Zenith, like into the Zenith representation of the same. So then I have an ERC20 that's USDC X or however that thing is called. So I go and send my transaction. That transaction kind of like gets queued until like it gets sent to the part of this transaction will be the USDC contract, and then part of the transaction will also be the kind of canonical Zenith contracts. I would assume there's probably like more than one that are involved. And then we wait for like a couple or like until the next block gets sent by the Zenith contract or like gets, I don't know, batched by the Zenith contract. And then like everything kind of like flows freely. Is that kind of like the correct understanding of how this would work?
Yeah, actually that's quite the way how it works. So essentially, you have our gateway contracts. Gateway is the atomic interop solution we built to allow that you can actually do cross-chain stuff without needing to wait for one leg or the other. Because, for example, on Ethereum, you have a roughly 13-minute finality, 64 blocks or like 2 epochs. On Canton, it's a BFT-based consensus. You have 4 or 5 seconds deterministic finality. If you use, let's say, Chainlink's CCIP to move an asset from Ethereum to Canton, then in order for that to finalize, you have the Canton side potentially ready in 5 seconds, but you have to wait 13 minutes for the EVM side to finalize and for the transaction to be final. In our case, as you mentioned, your wallet contract will be included. Zenith's canonical contracts on Canton will be included to do the block building. And then the gateway contracts that are able to take the Canton leg and your asset and do the locking on Canton in the escrow, do the minting on the EVM in the EVM gateway contract, and then depositing it to your EOA on Zenith. They are able to take care of all these steps in a single workflow parallel, and only if all legs are confirmed as successful, then does the transaction get finalized on Canton. If not, then simply your transaction will not have the necessary receipts, and it's not going to be part of the finalized block on Canton. And thus also the Canton side of the transaction is going to revert because the EVM side is not finalized.
Okay, okay, understood. That was now I think we're there. And now, like, this was a very simple use case if I just deposit my assets. But like now we could also think like you can batch even more actions after this, and it's like, okay, I'm JP Morgan, and like I have some assets that are somehow let's say it's an RWA representation of, I don't know, physical gold or something like this. And then now I want to use those to maybe borrow against them. But for that, I need some kind of Morvo or Aave or like some kind of like smart contract functionality. I think like currently in like this seems to be like a big use case of Canton more generally, of like I think credit lines is just like the overall general term. But maybe if we just think about this in terms of like, how do you call this, collateralized lending? I think that's like the official term for this. So we could kind of like, I could take my physical gold representation that maybe just lives in the JP Morgan subnet, or like JP Morgan is the issuer of this. And then if there's like a market for this first of all, I would need a bridged representation inside of Zenith that's kind of canonical. So like somebody needs to, I guess, is there like is there a permissionless bridge from like the Canton all the Canton subnets and from all the Canton issuers to, like, can I convert any CIP 56 into an ERC20? Is that?
Yes, that's
Okay.
that's the interop solution we built into our protocol to ensure that no application needs to deal with that complexity. No additional integration is needed for them to with bridges, etc., etc. The protocol itself takes care of the asset movement. And you are right. So you can think about it as, for example, you have this RWA representing, let's say, gold. You can take that, move it to Zenith, then deposit it into a vault, let's say, or into a vault. Yes, borrow against it, and then move back the USDC that you borrowed on Zenith to Canton. You can imagine all these legs to be executed in a single transaction atomically. So it's not like one by one, and you have an execution risk of one leg executing while the other doesn't, and then you need to take care about how do you revert stuff. In this case, and that's the core value proposition, EVM finality is deterministic in a few seconds versus the probabilistic finality, for example, of Ethereum in like 2 epochs. And that's because we are using Canton as the consensus layer over or underneath the EVM execution stack.
Wow, that opens up a whole new design space, because
exactly.
That is so interesting. suddenly, like all of the RWAs that are like sitting on Canton that like usually have like limited mobility and like functionality because they are in Canton, and Canton doesn't like, they support smart contracts, but like there's no Morpho, there's no other. I think there's like first early innings of like some decentralized exchanges, but like now if this was actually in production, I could just deploy like a Uniswap v3, Uniswap v4, whatever, and like actually just kind of like swap my physical gold to a USDC representation, and I just kind of like go in and out of the Zenith EVM in like one step or like in one transaction, and like I don't even notice, like it happens in the back end, and like I don't even really realize that like, oh, there was like an EVM transaction that like settled all of this in between. Is it?
Yeah, exactly. So basically, I think you are actually totally right. So this opens up a whole new design space, because the two environments, Zenith and Canton, are actually acting as one unified environment and one unified liquidity pool, basically. So even if your application is deployed on Zenith, because of the atomic composability and the ability to process EVM events within Canton workflows natively, it opens up a whole bunch of new use cases, which are simply just not possible in the EVM ecosystem currently, because all the chains have their own execution and consensus protocols. They have their own various finality times, etc. And basically, usually the slowest chain drives the finality. So if it's an asset movement from an optimistic L2 to the L1, then it's 7 days, which is pretty crazy.
Yeah, it's wonderful. I think, Denning, correct me if I'm wrong, is this a based rollup in like old Ethereum language? Because like you kind of...
You are making a very good parallel there. It's not exactly a based rollup. I don't know if you're familiar with the native rollup or the enshrined rollup.
Yeah, I think something like, it's been a long time, but we've been on this podcast before talking about these things.
Yeah, so Justin Drake brought up besides the based rollups, there was this concept by him called native rollups or enshrined rollups, where the actual sequencing and block building of the rollup is happening on the base layer. That's what you see basically with Zenith. The actual block building of Zenith is done by Canton validators. That's why we actually are very far from being just a regular L2 or a rollup. We don't have another term for this yet. We rather call it as an extension, because our execution depends on the base layer, and it's not like we just settle back to Canton like EVML2 settle to Ethereum, but they have their own entirely separate execution space. But we are more an enshrined extension to Canton. So that's a very good parallel, actually.
Yeah, I see. Wow. I think that the coin has dropped for me. I've understood this. But now my next question would be like, Ethereum state can get quite big. Like if we look at chains like Binance Smart Chain or like Mega ETH and like all of these different designs are now out there, and like actually state growth is like becoming like a considerable problem for all of them. So like how do you think like maintaining a state within a smart contract on Canton will kind of like fare over time, or like what's kind of your like approach to this design question?
That's actually a very, very valid observation. The thing is that without compromising any of the functionality, we are able to do the block building and all the atomic composability without posting every single call data byte and every single EVM payload byte to Canton. So state growth, I think, will be a thing. The Canton validators are Canton validators that run the EVM node. Yeah. They need to take care of that. But we do have kind of like the path in the future to address this as needed with regards to the state growing on the Canton side.
Okay. Yeah, I mean, sounds like a maybe not easy engineering problem, but it doesn't sound like it wouldn't be solvable. And like I think, yeah. So yeah, basically the contract just holds kind of like language is hard in these cases because you need to be specific, but it's also very hard to find the right, like the contract only holds kind of the proofs that like the transactions were kind of like the Canton native contract, and only holds kind of like the, I don't know, hashed results or like proofs or something like this that basically like indicates that something was correctly executed and the current state of the chain in like some kind of like very hashed format.
Actually, in the current format, we store the actual payload in the Canton contract. So it's a couple hundred or a couple thousand bytes per transaction that is stored in the contract. However, you can also think about it as you can store a pointer to these payloads in an external data availability layer, for example. And then when it comes to the EVM execution, the EVM nodes just take the payloads from there. I think for them, kind of. And you could actually, another term that came up. Yeah. So you could actually, how should I put it? You could actually either decide to put all the bytes, the full payload onto Canton, the full EVM payload onto Canton, or just put a deterministic pointer to where the payload lives, and then all the EVM nodes take it from there, and the results are still executed or compared the same way as it would. So it's kind of like, while it's an engineering problem, it's still not as complex as it may sound. But regarding what events have been executed, because what we talked about so far regarding this topic is when you initiate transactions, what do you store in the contract? But once the transactions are processed, basically you have the new state root of the EVM on Canton, from which you can derive all correctly executed transactions and verify all of them from within Canton. So that's another angle of it, but it's not like the amount of data we store on Canton basically allows or disables whether you can rebuild Zenith state purely from Canton, or you need to have access to that external DA layer to rebuild Zenith state. Our initial approach is that we want to have the Zenith state be rebuildable from Canton, and we send all data through Canton. But if that becomes a bottleneck, we do already have a solution for that, which is fairly easy to switch over to.
Okay. Interesting. So now we've talked a lot about the theory and like all of this. Who's actually using this?
Yeah, I see. So we are currently very close to a public testnet announcement. Like the tech is entirely built end to end. We've demonstrated both an early composability solution to Canton back in February. And then just very recently, a couple of weeks ago, we demonstrated the end-to-end atomic swaps, for example, between Canton users, EVM wallets on a Canton native exchange. And so the technology is entirely built. The end-to-end flow works. We are hardening our testnet and coming out soon with the announcement on that. Anyone can use the testnet permissionlessly and deploy applications on Zenith, etc. And on the other hand, for anyone who is curious, our docs already include, I think, quite a bit of interesting details on the architecture and on the upcoming testnet. But who is using us? We are in touch with a whole lot of developer teams and application teams from the EVM and the Solana side. I mean, we are talking about hundreds of teams here who are looking to tap into Canton's institutional flows and are considering to deploy to Canton through Zenith. We are also having discussions with financial institutions, with telcos, etc., around different pilot projects that we are looking to facilitate. We recently joined the tokenized JGB working group led by Progmat. It's basically revolving around finding the right solution for tokenizing Japanese governance bonds, and enabling use cases where you can borrow against those, exactly as the use case you mentioned, like use them as collateral, borrow against them in a lending protocol, etc. And we've been running and piloting workflows already related to this, which proves the capability of Zenith to handle these types of workflows where an RWA is issued on Canton, but then you want to use it as a collateral. You want to purchase it from the Zenith side, and you want to use it as collateral in an EVM vault on Zenith. That's entirely possible, including all the post borrowing monitoring of EVM state, whether the liquidation is needed, what's the loan health, etc., and passing back all that EVM data to Canton, off of which then Canton workflows can branch out and trigger liquidations or trigger release of the RWA if there was a repayment, etc. So these are kind of like the discussions that we are having with various parties at the moment. And one of the more concrete ones that I can already talk about and that we have already announced is participating in the working group for the tokenized JGB and participating as an infrastructure partner there to see these workflows running across Canton and Zenith.
Yeah, very exciting. I can imagine that a lot of DeFi apps, DeFi protocols, and just in general, like on-chain developers or teams that have historically been present on EVM networks or even Solana networks are looking for greener pastures. The TradFi is the only business left in town. I mean, there's still some gamblers left on chain, but I think as the space kind of like matures into just being rails for traditional financial institutions, certainly there's lots of new opportunities to be had, and I think a lot of teams, frankly, are also just forced to adapt to this new world. Super interesting like learnings and episodes, and like this opens up a whole new branch of the Canton network in my head, where like suddenly we can kind of like have the global, like one global state that actually, like, I think just simple things like, oh, there's a USDC, USDT liquidity pool that just anyone can kind of like swap in and out of very easily. And like, sure, like I frankly, I know too little about Canton usually, of like thinking about like, is this really the like most efficient way to do this, or like could there just be like a DAML program that does this? But also there has been whatever many 7 years of innovation of like on-chain exchanges in the EVM space, and like instead of just being like, oh, like let's just like discard all of this, let's start anew, it's like suddenly we can bring all of these innovations and the battle tested contract and all of that stuff. So like I think a lot of other ecosystems historically have had the problem of like, oh, like now we're on Aptos and like now we need a new lending market. Then it's like, oh yeah, like in total the ecosystem will spend like 20 million on audits and like making sure that the contracts at work and like all of the stuff. And now you've just kind of been like, if this thing you're trying to build works out as you currently portray it, then it's like, oh, we can like shortcut all of this, and like suddenly we have all of this composability. We have all of the kind of like good things that exists in Ethereum, in Solana. We just have them natively on the network, and suddenly it's like very powerful, and hopefully all the institutions can like use this composability in their advantage to make on-chain finance more efficient. Very, very exciting. So now I'm hopefully I can join your marketing team now. But thank you so much for coming on, Norbert. I think this was super interesting. Maybe what's the thing you're most excited about in kind of like the next couple of weeks? Maybe beyond the testnet launch, because that's the obvious answer.
I think what I'm most excited about is the actual pilots that we are running and that we have lined up, because those will actually prove that all this, technical work that we've put in is maturing into Canton EVM cross-chain flows, where Canton Zenith cross-chain flows, where you can actually put the technology into use for real-world use cases, for financial institutions to benefit from it, and also actually I think for retail to benefit from it, because there may be also people on Canton who have significant Canton coin exposure, and then if they want to have potential yield-generating opportunities through that, or want to have access to a wider range of assets through Zenith EVM, I think we are bringing a whole lot of like opening a whole new space in that sense as well for any Canton user, including the institutions.
I mean, the institutions are going to be the ones that matter.
Yeah.
But anyways, Denning, any last things you wanna leave on this topic?
No, yeah, I think like after this episode, I just get to know how little I know, but at the same time, my take is that it seemed like Canton historically has been institutional driven, and like we don't really see any of the like application or interface that's really getting exposed to consumer side to understand better. But with the Zenith layer, I can imagine there's Uniswap, there's like all kinds of apps and wallets that we are familiar with to interact with. So my way of understanding this like launch is actually opening up the consumer face, as you said, as one of the point. I think that also a very successful case to look out for would be one day if I just swap on Uniswap or any other chain, there's a liquidity pool says, oh, this is the USDC liquidity coming from Canton. And you can say, oh, I'll swap it. And people don't need to worry about like, okay, I have to bridge over to Canton or anything. That is being enabled by Zenith. So I think like, yes, like composability to, introduce liquidity from all the other existing EVM is interesting for Canton, but also the other way around is also going to be very educational and like good exposure for Canton.
Oh yeah, we haven't even mentioned that you can bridge the whatever RWA gold issued on Canton via Zenith to another EVM network, and then probably do stuff with it. I guess that's, or is that possible, Norbert? Did we understand something wrong?
Yeah, I mean, CCIP and Layer 0 honestly are also already available, if I remember correctly. Maybe it's only
I mean,
CCIP.
one of them will come either
But
way.
yeah, so they can already do that. Our core proposition is that if these assets, EVM assets, live on Zenith, then both Canton's institutions and clientele are able to tap into that atomically, without leaving the garden, basically. Because as soon as you leave the garden and use some external interop protocol and you go outside Canton, you go into trusted parties, you go into different legs executing with different timeframes and finality, etc., with all the risk and all the conditions that it comes with. I think for us the core value proposition is EVM applications connected to Canton atomically, and Canton applications or clientele having access to all these EVM events, all these EVM applications, all these EVM assets, etc., that are already circulating, better tested in the past, 7-8 years of DeFi history.
Yeah. There's probably also gonna be some permissioning going on the EVM chain side, but anyways, there's 10 other conversations we could have here, but I think
and branch out to different ways.
Yeah, this serves as a great introduction to Zenith. When do you expect all of this to be like in mainnet? It's always hard to put a concrete timeline. As a product manager myself, I know how hard it is. But what's kind of the official plan at the moment?
We have a dependency on Canton network to deploy or to roll out a primitive that we built in DAML directly, which allows all this composability. This requires a whole new network release on the Canton side. Canton 3.6 has to go live. It's coming early Q4, so only after that can we go live with mainnet, but we are looking to be ready soon after. I wouldn't put a more concrete date, but we are looking at late this year and early next year, potentially for a mainnet go live. Our testnet is going to have the full functionality already, so anybody building on Canton or Zenith can already very soon test out all these workflows, deploy applications, and prepare for the mainnet launch. And as I mentioned, our docs include a whole lot of details for anyone interested.
Cool. So Q5 2026. Just to throw that joke in there. No, Q4 is actually not far away. I was like, oh, Q4,
no, but anyways, earliest could be Q4, but we'll see when we land there.
Yeah, Q5, classic. Anyways, thank you so much for coming on, Norbert.
Thank you very much for having me.
This was fantastic, and thank you for listening to the Index podcast. We will see you in 2 weeks. Bye-bye. Crypto day wizards, come join us for the parade. From Bitcoin ETF to Solana meme coin trade. Uncovering public secrets in the blockchain shade. Bad chiller, cherry picking liar. We call them out and set chart crime on fire.